light shaft carries a single disc whose center of gravity is at a distance e from the shaft axis. Okay, so this is the eccentricity. The whirling speed is 3,600 revs per minute, and at a speed of 3,240 revs per minute, the center of gravity revolves in a circle of radius 3.8 millimeters. Calculate the distance e. Okay, so right, this is our formula that we use for the deflection. And what have they given us? Well, they've told us that the whirling speed is 3,600 revs per minute, so that's 60 revs per second, and the speed is 3,240 revs per minute, which is 54 revs per second, and the center of gravity revolves in a circle of radius 3.8 meters. Okay, so this is let's say this is the center of gravity of the light disc, the single disc, sorry, and it's at some value e. I'm just going to draw this in. Let me get a different color. Yeah, we'll do red. Okay, so that distance there is e. But you know, when we put a load on the shaft, it's going to deflect. So it's going to deflect by a distance d. And then the centrifugal force is going to act on it here, and that's going to cause it to go out another distance y. And we have the eccentricity e then as well, okay, to add on to that. So basically what this is telling us is that this distance, 3.8 millimeters, this distance here, is the sum of the deflection d, the static deflection d, the deflection y due to the centrifugal force, and the eccentricity. So there's, let's say, the deflection d, there's the deflection y, and there's the eccentricity. So what this sentence is telling us is that d plus y plus e is equal to 0.0038 meters. Okay, so that's what they've given us. Now the whirling speed, NC, is equal to 1 over 2 times the square root of the deflection, the static deflection. And we covered that in a previous video. So if I have NC, which I do have, I can work out what the deflection is. So NC was 60, so 60 equals 1 over 2 times the square root of d. Solve for d, and we have the deflection is 69.5 micrometers. So if d plus y plus e is 0.0038, so this value here, then I can put in for d, and we can get an equation for y plus e. So y plus e is equal to 0.0037305. So we'll just store that up here for the time being. Okay, y is equal to plus or minus e over 60 squared divided by 54 squared minus 1. So it's just this equation here. And when we solve that, we get this part of it here. We get e over 0.234. That means e is equal to 0.234y. Now I'm only going to use the positive value and not the negative value, because when we drew the circle, I had shown y going in this direction, and that was the positive direction. Okay, so we're just going to use the positive value. Okay, so if we take this equation here, y plus e is equal to 0.0037305, substitute for E being 0.234y. We have y plus 0.234y is equal to 0.0037305. So y is equal to 0.0037305 all over 1.234. That gives me y to be 3.023. I'm going to multiply that by 0.234, and that gives me my value E, which is 0.7 millimeters.